Right, so this is carrying on with the second half hour of grade 11 choice 1 on the 1st of July. You know what, I think it doesn't switch on the first press there. It doesn't record, it's still on standby, I think it goes on standby for a little bit of time and then he starts. It switches off. Okay, ladies, you're okay. Okay, the gentleman, are you okay? All right. So this is a micrograph of a cross-section through a spinal cord, and what you can see here is meninges around the outside. Okay, you can't see the dorsal groove or dorsal fissure because it's so narrow, and in this slide it's pushed together. This is the ventral one. Okay, there's a blood vessel.
Could you just, thank you.
Sorry. Okay, so there's the ventral one. There's the central canal. It's continuous with the fourth ventricle in the brain. And what you can see here is this butterfly shape of grey matter, and then you can see white matter. So in other words, this would be the dorsal root out here, but you're not seeing it. So a neuron would come in here. It would synapse with an interneuron within here. This would synapse with a motor neuron somewhere down here. And then out goes a neuron there. Okay, right, you okay, guys? That makes sense?
Yes, ma'am.
Okay. That shows exactly the same thing. Okay, and so does that. And then this is a model which just shows you everything that I've just said to you. So this would be a mixed spinal nerve and a mixed spinal nerve on that side. The swelling here is the dorsal root ganglion. So all the sensory neuron cell bodies would lie here. That's why it's fatter there than it is the rest. And then these are sensory neurons going into the spinal cord. Here's that butterfly shape of grey matter, and then you can see all the white matter. Okay, and that's neurons lying on a different plane. And then this is motor multipolar neurons forming the ventral root, and then here is a two-lane street. Don't say that in a test or exam because it's a mixed spinal nerve. Okay. Right, guys. Okay. So a reflex reaction or a reflex action is a very fast automatic response to a stimulus, and it doesn't involve the brain directly. Most of these actions occur without any thought at all, and the importance is that they are actions that protect the body from danger or injury. Because if you're standing with your hand on a hot plate in the stove, by the time your brain has processed that and it's going, this is really very hot, I wonder what I should do, maybe I should move my hand, okay, moving my hand now. By then you've already done dead injury. Okay. Right. Another example of a reflex action is pupils dilating when you walk into a dark room. You don't have to think about it. Okay. However, there are things that are called conditioned reflexes. And conditioned reflexes or acquired reflexes are reflexes that can be learned to enable carrying out of complex activities without difficulty. So if you remember back in the day, learning to ride a bicycle, it was really quite difficult at the time because you had to think about balance and blah blah and thingamy-bob. And after a while, it became a conditioned reflex. You don't think about it. And it's exactly the same. You're going to find exactly the same when you learn to drive a car. When you start driving a car, it's actually quite difficult to remember. Well, a manual car especially, you've got to remember to do the clutch and the petrol and all sorts of things. And it's just quite difficult to remember to do all the different actions, but very soon you do it without thinking about it. So what's the difference between a reflex arc and a reflex reaction? A reflex arc is the pathway that leads to a reflex action or a reflex reaction. So if you asked about a reflex reaction, it will be a stimulus, stimulates a receptor, that sends an impulse through a sensory unipolar neuron, through the dorsal root to the spinal cord, and it then synapses to a connector or interneuron in the spinal cord. That synapses with a motor neuron within the spinal cord, which transmits the impulse to an effector, and there will be a reaction in the effector. They're very fond of giving you this diagram here that I've drawn on the board, or asking you to do like a flow diagram of this thing. Okay, remember the rules of flow diagrams, guys. You have to have a heading. Okay, and then remember it's short phrases or individual words going down the page, not snaking, with arrows in between, with no clouds and no boxes. Okay, so reflexes don't involve the brain, although in some cases the brain can override and prevent a reflex action. So an example would be, you know, the reflex action, the knee-jerk reaction. You know what I'm talking about when they hit the knee and you kick out like that? You can override it by thinking about it beforehand. But most reflex actions you can't override because you don't expect them. Okay, so this is a good diagram of a reflex arc. So here is a unipolar neuron. You need to draw the dendrites there. And that unipolar neuron will send an impulse through a mixed spinal nerve into the dorsal root ganglion. So there's the cell body of that unipolar neuron, and then it enters, there's the axon of the unipolar neuron, and within the spinal cord it synapses with an interneuron. So there's a synapse, that's an interneuron, it's a multipolar neuron, which synapses with a multipolar motor neuron, leaving the spinal cord through that mixed nerve there, through the ventral root, and going to that muscle there. And the muscle in this case is an effector. Okay, so you need to know where to put all the different parts. You need to know that this is the sensory unipolar. You put the cell body in this little bulge place. You put the synapse within the grey matter, and this synapse within the grey matter. And then the multipolar neuron comes out of the ventral root. Goes to an effector. Right, does that make sense? Okay. Alright, so there's an animation there, and that just... And then finally, diseases of the nervous system. But I think that's enough to do for today. We'll leave this until the next lesson, which is Friday, and that's before we return break. Is that okay, guys? Any questions? Ladies? Who did we lose? We lost a third child. Fourth child. Sam, you okay?
I'm good, ma'am.
Chloe, you okay? We lost Kimberly.
I'm good, thank you, ma'am.
And is Misa there?
He's sleeping.
Oh, okay.
Jen, are you okay?
I'm good, thank you, ma'am.
Sure. Okay, guys. Alright, then we'll leave the diseases of the nervous system until next lesson. And I'll say goodbye now. Okay. Hopefully, wait. We can't leave it till, no, wait, I'm cancelling that. You can't leave it till next lesson. When's your next lesson? Friday. And you've only got 1.5 hour on Friday. No, wait. No, I'm lying. You have got a lesson tomorrow. Okay, yes, we're leaving it then. Okay, you may go. Because I need a half an hour next lesson to go through the test. Okay, bye guys.
Bye, ma'am, thank you.
Bye,
Bye,
pleasure.
thank you, ma'am.
Pleasure, bye.
Oh, yeah. We don't see you on Friday.
I've got a thing here that I see tomorrow.
Yeah.
You don't see me on Friday. So we've got a full hour tomorrow. I'll do the diseases tomorrow, and then I'll go through the test for the rest of the time.
Which one? The class test or the cycle test?
Yeah, no, the cycle test.
Oh. The one where like yesterday. That was great, man.
I haven't marked it yet. I've only marked half of it. I hate not marking immediately. But the problem is because now you know the tricks aren't here. So we all of a sudden had to switch from teaching them in class to teaching them online. So that involved a huge amount more work. So that's what I've been doing.
That's hectic, man.
Okay, now I'm not allowed to let you out. So do whatever you want to do until the bell goes. How's that? But okay, do some learning. I know I said do whatever you want to do, but I changed my mind. Do some learning.
How long do you want to do?
I'm a bit worried that you don't know the neurons. So that's the end of the second half hour of grade 11 choice 1.